All right, we're going to run through all the operations that you are familiar with and then one that you are not so familiar with. But you should have done it before. So we're going to do addition, subtraction, multiplication, division, and then we will hit on composition. Oh, don't be so excited, Silas. I know. Just contain yourself. Contain yourself. So the 4 will go quickly. Composition not as quickly, but that's okay because it's still not bad. All right, so let's define some functions. Let's say I have f of x equals 4x to the 1/2 and g of x equals negative 9x to the 1/2 and h of x equals, oh, I know, it's not that bad though. 2x to the 3/4. It indicates that it's a function. It's like, I mean, yeah, it's the same as y, but it tells us that it's a function, meaning it passes that vertical line test. Every input has one and only one output. Definition of function from Algebra 1, yes. Looking at me like I am crazy right now. All right, so let's start with addition.
I went to look at your clock. I know this is so off topic.
First, if we're adding, what I mean is I will define some functions and then I'll say what is f of x plus g of x.
Oh.
Okay, so you look at the functions that were defined and we say, okay, well, f of x is this, right? And to that I want to add g of x. So can I add those together?
Yeah.
Why? They're like terms, right? So this becomes negative 5x to the 1/2. I'm going to assume I don't need to do anything else with addition. Easy. It's just like when we did polynomials, only now I'm looking at fraction. Everything about this chapter is the same concepts. It's just that now the exponents are fractions. That's the biggest difference that I can tell you in a lot of this anyway so far. Yeah.
Well, what if the exponents aren't the same?
Then you would just leave it written like that. Like if I said what is f of x plus h of x. So 4x to the 1/2 plus 2x to the 3/4. Well, I can't combine those, so I would just leave it written just like that. You can't force that one that way. Then your base would be changing. So you just leave it. You just leave it. Think about if it was, yeah, if it was 4x squared plus 2x to the 5th, you would just leave it because you couldn't combine them. So it's the same concept. Does that make sense? Okay. What if I subtracted them? So what if I said, what is f of x minus g of x? Same thing, right? 4x to the 1/2 minus negative 9x to the 1/2. And so I'm looking for like terms. And I know I'm not delving too deep into this. And if you need me to do more, tell me. Just say that again? That's correct. It's a fairly easy concept. I feel like, but if you need me to do more, tell me. And I'll go a little more in depth.
You're doing the subtraction with the 2x equals to the
Say that again?
if you
Yes, you'd leave it.
But
Yeah.
for the fx plus hx, if you can't combine them.
Yep. I'm going to leave these same functions up here because I'm lazy.
Hold up.
I can hit undo. It's the blue circle of death.
I got it, go ahead.
What's the blue circle again?
See it?
The ocean. Wait, why don't you like that?
No, I said.
I had to wait on that blue circle. It wouldn't let me do anything else. You good?
Yes.
See it? See it?
It looks like my Cheerios.
Let me. Okay. All right, let's move on. Let's move on to multiplication.
Yes.
Using the same, see? I don't understand why erasing is hard for the software.
But then you can look
Because
at
they
it
want
and
you to
just
keep
see
writing
like,
instead of erasing. Because erasing means that you made a mistake.
Does not like erasing.
You erase this like this, y'all.
And let's do multiplication. Actually, let me define one more.
We
A,
just did multiplication.
Wait, so if it can't go together, if it can't go together,
it's the same thing.
you made it unpretty.
You just leave it.
Wow, okay.
there's j of x.
So time out.
Okay.
So if you were like to multiply, let's say we did f of x times j of x, we'd write that whole thing out like that.
Yes.
I know.
All right, the first one I'm going to do is f of x times g of x. Since each of those are only one term here, it should be fairly easy. What is 4x to the 1/2? And y'all have done this. This is what you just quizzed on. Negative 9x to the 1/2. When you multiply terms like that, what do you do? Negative 36.
Hey, to the one. No, wait.
Oh, I know you add them.
You add them.
You add them,
Big one.
so you're done. Yes.
Wait, I thought you couldn't do that.
When you multiply terms, you multiply the numbers in front and you add exponents.
You only multiply them when you have power.
Right, you're getting, now you're starting to try, you're thinking about properties of exponents and getting them mixed up with the properties of multiplication that you already know. This is just a multiplication problem. And so we multiplied what we could together. What if I asked you to do h of x times j of x? Yes.
Wait, why is there no exponent on that?
It's a 1. You added a half and a half.
I don't know.
All right, so h is 2x to the 3/4. And j is x to the 1/2 plus 3. So, yes, Joseph said we distribute, and that we do. It is, isn't it? It wasn't fun? 2x to the 3/4 times x to the 1/2 is what? 3/8?
Yeah.
I don't know.
I made it where it was like 3/4 plus 2/4.
Yeah, I thought
Like basic.
you actually.
4, 2, it'd be 7.
Wait, no, you multiply them because it's.
No, you add the exponents.
What? So you're gonna stay.
3/4 plus 1/2. If I make them both have a denominator of 2, would multiply top and bottom by 2. So it'd be 5/4.
So we have to add that.
Yeah, I thought when you like distribute, then it's like you're multiplying
Yeah,
everything
don't you
together.
multiply?
You do. So 2x to the 3/4 times x to the 1/2. When I multiply, they add the same base. When you multiply with the same base, you add the
Because you're not
exponents.
distributing it.
Right.
So if
What
it
got
have
me?
the same base,
I thought it was
I thought we were just.
You did power of a power.
Wait, how do you? I missed it. They don't have that.
Because a power of a power is when you have, if I had 2x to the 3/4 raised to the 1/2, that's a power of a power. That's when you multiply. But because this is multiplying, I add the exponents. All right, guys, y'all stay with me. When I multiply to the second term, I get 6x to the 3/4.
And then you can't do anything.
And they can't do anything else.
Added all the power in.
If you start getting confused, think about if the exponents were whole numbers, what would you do? And you wouldn't have any problem doing it then. It's just throwing you off because of the fractions. I'm telling you that's what's throwing you off.
Why can't you do these?
They are the same bottom, but they're not the exact same exponent, so they're not like terms.
I didn't know if you had looked at some.
All right. Let's do this time, let's do j of x times g of x times h of x. Whoa. Yeah.
I know.
Don't laugh.
All right. That was a mwahaha. Times g of x is negative 9x 1/2, and h is 2x 3/4. The plus sign in the first parentheses is going to be what throws us off, right? Because that indicates I'm going to have to do some distributing. So what I would like to do is multiply these two together first and maybe move them to the front so it's a little bit easier to see. So multiplication is commutative. I can do it in any order I want to, right?
Yes.
All right, so my question to you then is, what is negative 9x to the 1/2 times 2x to the 3/4?
Negative 18x to the 5/4.
Is anybody confused on that? Multiply coefficients, add exponents. So to that, I need to multiply x to the 1/2 plus 3. And the only reason I moved it to the front, it's not necessary. I just did that so you could easily see it distributing through that way. All right, nothing to it but to do it. Negative 18x to the 5/4 times x to the 1/2 would give you negative 18x to the 7/4. That is correct. Minus, what is it? 54?
That's nasty.
It is. All right, that is addition, subtraction, and multiplication. How about division? Division's easy because, yes, I'm just looking for the, I can't really do a lot when I'm adding or subtracting in the top or the bottom other than splitting up fractions. The main thing I'm going to have you do with division, I'll show you. I like to reference the same function so we don't have to keep coming up with new ones. Wills, you're just going to have to look at those little pink dots right there. I'm sorry. Did you say This is for you, Wills.
Now it's
I of X.
That's worse? Why?
Now it's I of X, not G.
It's the incredible time.
Y'all just complain too much. Okay, that's right.
It's abstract.
There's one more dot.
There's one at the bottom.
There's one more dot.
That made me color on my jeans.
It's centered.
What happens if you divide those two functions?
Yeah.
I'm assuming this is true. I've never killed anybody yet.
What?
Yeah.
I don't know. I love how you get as long as you start with this. I love her yet.
I heard subtracting, yes. Simplify the coefficients, subtract the exponents. So 4 divided by 2 is 2. And when I subtract 1/2 minus 3/4, what do I get?
Wait, I thought we negative. We can do this now?
Negative 1/4.
Wait, hold on.
What?
That's 1/4.
1/4, man.
Both of what? I'm not, these are different, these are, okay, I think I see why y'all are getting confused. I'm not actually doing both because what I'm doing, this is a coefficient in front, so it's its own piece. Now when I look at the base with the exponent, the base is x, the exponents are here, so I'm going to combine the exponents, not the bases. But 2 and 4 are not the bases there. They don't have anything to do with that right now. They're their own piece because it's actually 4 times x to the 1/2. So think about it like this if it confuses you. Think about, come on, one more time. Think about it as 4 over 2 times x to the 1/2 over x to the 3/4. If it confuses you as to doing both things.
Man, that's a bracket.
Whew. That was not my fault. Okay. And that's the same thing. It's the 4 over 2 could be pulled out and not looked at. It's not part of the base. All right, so I got 2. 1/2 minus 3/4 is what? Negative 1/4. Uh-oh.
Wait.
Flip the X to the bottom.
Just the x, but not the 2, because remember the 2 is separate. It's 2 times x to the negative 1/4. So I want the 2 to stay in the top, and I want the x to the 1/4 to move down.
Wait, how did you get negative? Because
1/2 minus 3/4.
I did that whole back. My bad. I got 1/4. I just didn't.
Didn't. Gotcha. Tell me what you think.
It bothers me because there's a fraction.
I just don't have
Sorry.
the
Fraction was.
Fraction.
You can't make it so radical because you just have radical.
Focus. All right, one more. Let's say I had, in fact, let's do this. Let's do 2/3 times f of x. What did I use on the last one?
H of X and F of X.
H and F. Then let's make this one G times, and we'll do J again. Oh my goodness, y'all, it's a G. All right, so now I have a scalar in front that I'm also going to have to multiply by, okay? Which is just a number out front you multiply everything by.
You just multiply.
All right, so look, 2/3 times G of X is, I'm going to put it in parentheses for you, negative 9x to the 1/2 times x to the 1/2 plus 3. Okay? Again, I want to save the distributing for last if I can. So let's multiply the number in front and G of X first. What do you get?
So you get 6, negative 6x. Because 2/3 of negative 9 is negative 6.
Oh, I didn't mean to let my fraction cancel out. It's okay.
Because that's technically just like a 2. Just
Right.
weird.
And now distribute. Negative 6, what do you get? X to the what? To the 1. Minus 18x to the 1/2, that's correct. Let's compose. J of X divided by H of X. So J of X is x to the 1/2 plus 3. And H of X is 2x to the 3/4. Okay? Now, because I'm adding in the numerator, this only works when you're adding or subtracting in the numerator, not if you are adding or subtracting in the denominator. When you are adding or subtracting in the numerator, again, this is a rule of fractions, okay? Split them up.
What did you just say?
Yeah, time out.
You just wrapped that.
I wrapped it?
Yeah, like, I said that like so bad.
Okay, this, what I'm fixing to show you only works when you're adding or subtracting in the numerator of the fraction. That's the top, right?
Yeah.
Okay. If you're adding or subtracting in the denominator, this rule does not work.
Okay.
Okay?
Don't say anything.
Yeah, I'm fixing to tell you, okay?
So,
So I don't want you to get confused. If this were flipped, this would not work this way.
okay.
But when you're doing it with an add or subtract in the top, you can split the fraction up. And you can split it up into this. Y'all should already know this. Plus this. It's the backwards of adding, y'all. If you have common denominators, you can combine the numerators over the same denominator.
Didn't know that.
I'm just the backwards of that.
Where would I even have
Okay? So you can't, but you can't simplify if you don't do this.
So you have to do this.
Yes. Now simplify each piece. Look at it. If you look at it, you should see. It should make sense to you what we did. If I gave you just this, you would say, oh, the bottoms are the same, so combine the numerators. Right? I just did the backwards of that.
Oh.
You just split it.
Yeah, I split it. All right. So, the first one simplifies. All right. 1/2. The 2 is going to stay in the bottom, right? Subtract the exponents. What is 1/2 minus 3/4? Negative 1/4. Plus, nothing here simplifies. There's only one x and 3/2 does not simplify. So plus 3/2x to the 3/4. Division problems are really just simplification problems with this. What? Yeah, we're going to move it down. So this would, I got to hold the place with the 1 because I'm taking everything out of the numerator now. 2x to the 1/4. Second fraction, same thing. That's all you can do. If you combine them, you would have to find common denominators, and by finding common denominators, you'd end up back where you started. Here we go. Composition. If I told you, all right, these are new F's and G's and everything else, so draw a big line in your notes or whatever. All right, if I told you that f of x was 3x plus 7. Okay, simple linear function, right? What if I asked you, well, what is f of 2?
You plug in a 2.
Tell me what you do. You plug in a 2 for x, right? That tells me that everywhere there was an x, I'm plugging in 2, so I would put it here and keep going, right? And Joseph says that's 13, and it is. Okay, what if I asked you, what is, squiggle. What is f of Bella?
You plug in a
You plug in a Bella for x, right? Okay. The point that I'm getting to is it doesn't matter what's in those parentheses. Whatever is there is what is replacing the x, right? What if it was f of x plus 2? Then this now becomes 3 times x plus 2 plus 7, right?
Which would be 3x plus 13.
Which would be 3x plus 6 plus 7, which is, yes, 3x plus 13. Easy? What if...
It's easy.
It's easy till you get home and do it yourself.
Exactly, thank you.
What if I now define g of x to be x minus 10, and now I say, what is, can I erase these? Y'all so nice. Wills, that little yellow dot right there is just for you. What if I asked you to find f of g of x?
X minus 10 for x.
You're exactly right. G of x is x minus 10. Do we all agree?
Yeah.
Okay, so put it there. So really what I'm finding is f of x minus 10. Right? So it would be 3 times x minus 10 plus 7, which is 3x minus 30, plus 7, which is...
3x minus 23.
You have just composed two functions. Function composition is plugging one function into another. Okay? Of course, they're not going to be little linear functions. These were for the sake of example. But before I show you slightly harder, let me show you a couple more examples. What if I asked you to find f of x?
So then you would plug in 3x plus 7 for x.
This is really saying find f of 3x plus 7. Everywhere there's an x, replace it with 3x plus 7. Okay. For the f equation. So you're taking this and plugging it back into itself there. So 3 times 3x plus 7 plus 7. It's like one of those pictures in a picture. Have you ever seen those?
Yes.
So if you were to do,
Those blow my mind, but anyway.
G of f of x, it would be 3x plus 7 minus 10.
It'd be done if we
Yes.
just did that.
Yes. 9x plus 21 plus 7 is 9x plus 28. What? No, you don't, Chandler.
It scared me.
She will do the instinctive for her problems. Look at that.
See if you can get this one.
I can't. Bet money. Bet you money.
F of G of X of F.
It's F negative 3. Okay.
Oh my gosh.
Oh my gosh.
Wait,
Okay,
wait, give me like,
We're plugging two different.
try it. Yes.
Give me 3 minutes. Exactly.
3 minutes. I'm going to pause the video for 3 minutes. So the way I go about these is I work inside out on these, okay? And the key is if you're plugging in a number and not a variable, then you should get a number back out. You should get an answer without any variables, okay? If you're plugging in a variable, then it should spit out a variable for you, okay? All right, so f of negative 3, I'm going to find first. F of negative 3 is 3 times negative 3 plus 7, which is negative 9 plus 7, which is negative 2, right? So we know that f of negative 3 is negative 2. So really what I'm finding is g of negative 2, right? Which is negative 2 minus 10, which is...
Okay, I got that answer. I got that answer.
I did it, but I just couldn't.
That's fine. Did you find f? Did you find g of f of x first and then plug negative 3 in?
No, I did. I did, 3 of negative 3 plus 7 equals x minus 10, and then,
Equals? Don't set them
well,
equal.
like, I was just like.
Oh, okay, I
at the
gotcha.
beginning, and then.
All right, let's see how good you are. I'm going to give you one final F, G, and H. We're going to do a couple compositions, and then I'll set you loose if you're good. Let's let f of x be 4x to the negative 1. Let's let g of x be x squared plus 4. And let's let h of x be 5x minus 2. Let's first find, let's do f of g of x first.
Your skin.
Do y'all know that?
Okay, so g of x here is x squared plus 4, right? So really what I'm finding is f of x squared plus 4. Okay. So f is 4 times x squared plus 4 to the negative 1. Yes. So listen, the question was, should we distribute the exponent or the coefficient first? And my answer was neither. Okay, and here's why. One, exponents come first in order of operations, right? Before multiplication. So clearly I need to take care of that first. But because we're not solving, we're going PEMDAS. So, because there's an addition in the parentheses, I can't just distribute an exponent, okay? So tell me this, what does a negative exponent do? It flips it. So the 4, this is its own piece, stays, and on the bottom, I have x squared plus 4. Well, an exponent of 1 is just an exponent of 1. I can leave it just like that. That is f of g of x.
That's the answer.
That's the answer.
That's the
You don't simplify that.
Yeah, that's it.
So
No, because remember, you can't split them up like you could the other one. Because it's in the bottom, not the top.
And basically, any time we do whatever is directly before the exponent, no matter like how much is in the parentheses, is always going to go.
Yes.
Wait, why don't we bring that up?
If it's on the outside of a parentheses, yes, it applies to the whole parenthesis. And generally, it's telling you how many times to multiply it together, but since that was a negative, I had to take care of that first. Now, had that been negative 2, I'd have had to put it down in the bottom, and then I'd had to FOIL it out.
Oh, yeah.
You see what I'm saying? If this had been 2, and it was like this, that would cause me to write it twice, and then FOIL it out. How about...
Why don't you cancel out those words?
Because it's different whenever it's in the bottom like that. It's not the same property as it being adding in the top.
So it's not just
You
one
can't,
over X.
you can't. You couldn't cancel the 4s out unless there was a 4 here also, in which case then you could cancel all of them out and hold the place here with a 1.
Oh my god.
But it'd have to be for all of them.
Let's say it was 4 plus x2. Wait, that's the same thing. Uh-oh.
How about this one?
I'm the first.
G of h of x.
I spend zero with children. That's just me.
I thought you hated it. I do.
You hate children?
I picked them, they're just so annoying.
Okay, I think they're annoying, but at least
This time I'm plugging h into g, and this time there is an exponent on the outside of a binomial, and so I am going to have to square this, which means I'm going to have to FOIL this. Which,
25x minus 10x
Uh-huh.
minus 10x
plus.
plus 4.
So that's 25x squared minus 20x plus 4. And the two 4's come together to give me 25x squared minus 20x plus 8. Let me make sure I've covered everything from your homework. I think you're good. You might hit a little bit of a hiccup on some of the fractions, but I think that you should be able to get through those. Yeah, what?
when I